Hello everyone, welcome back to Basic Integrals, example number 2. So right here we have an indefinite integral that has cosines, sines, and secants. I don't really like secants, so let's just start by rewriting everything as cosine 2x plus sine cubed 2x, everything over, what is secant? It's 1 over cosine. So 1 over cosine and then 2x. Don't forget the dx. Right here we can flip the 1 over cosine and multiply. So this is basically cosine of 2x, integral cosine of 2x plus sine cubed 2x times cosine 2x. We just flipped it basically, dx. And we can multiply this with this. So we are left with cosine 2x, not cosine 2x, cosine square 2x plus sine cubed 2x times cosine 2x dx. So now, if you take a look at this right here, this cosine squared 2x is a half angle formula. I'll be posting a picture right here somewhere on the screen so you guys can see it just in case you don't have it. But the half angle formula is basically integral of 1 plus cosine and then 1 plus cosine 2 theta over 2. But since we have a 2 here, we multiply the 2 here with the 2 on the formula. So that will give us a 4x divided by 2. And then right off the bat, we can probably split these two this integral, and put an integral here. So we have integral of sine 2x times cosine 2x dx. Don't forget the dx's. Okay, so now let me make this a little smaller so we can have some more room. All right, so now we see here we have a plus here, so we can split off this integral too. So that will give us a integral of 1/2 dx plus integral of cosine 4x divided by 2, but we can take that 2 out and put it in front of the integral. So we have 1/2 integral of cosine 4x and then plus this other integral over here. And don't forget the dx's like I'm doing. Sine cubed 2x cosine 2x dx. Right here, we can probably do a u sub right here. That way we can, if we do a u sub of sine, we can probably get a cosine. So if we let u equals sine of 2x, du is going to be cosine. Du is going to be cosine of 2x times the derivative of the inside, which is 2. The derivative of this inside. So 2. So we can basically put that 2 in the front. 2 cosine 2x. Don't forget the dx. So now we have cosine right here, cosine 2x dx, and we also have cosine 2x dx here. We're missing the 2. So we gotta divide by 2. These 2 cancels. So we have a 1/2 du equals cosine 2x dx. Now we can replace everything. So we have, I'll do it on the side. So the integral of 1/2 dx is just 1/2 x plus 1/2 integral of cosine 4 dx. The integral of cosine is sine. So we got sine. Well, actually, the integral of cosine 4x dx is 1 over a sine ax. I'll put the formula on the side. So we got 1 over a, which will be the 4, times sine 4x plus, let me make this smaller so we got some space. Move it to the side. So we have a 1/2 du is going to replace the cosine 2x dx. So we have 1/2. I'm bringing that 1/2 in the front. Integral of u is going to replace sine. So we got sine 2 dx. Sine 2 dx is going to replace u. So we got u cubed because we're replacing this. And then du is going to replace this. So if we do the integral of that, it's just basically u to the 4th, because we're adding plus 1 here, and then whatever we have, we move it back here, down here. So we got 4 to the 4th times 1/2. Basically writing everything backwards. Just rewriting everything. So we're going to simplify this. So it's 1 over 8 plus 1/2 x. So u is sine of 2x. So we're going to replace this u with sine of 2x. Running out of room here, so I'm going to make this smaller again. So we have, the answer is 1/2 x plus 1 over 8 sine of 4x plus 2 times 4 is 8. U is sine of 2x. Don't forget the 4, exponent 4, and then plus c. And that will be your answer. And c is a real number. Thanks for watching, and I'll see you guys in example number 3.